As soon as I will get water. One second, guys. I'm trying to make sure the camera is getting.
Go on, I'll go.
Awesome.
Sorry about that. If you ever see me yapping and it says the time when we start, just come and get me and throw me up here. I almost forgot. Welcome everyone to September's .NET Liverpool event. For those who have not been here before, thank you for actually finding us. We're a monthly meetup group, so we meet up once a month, usually every Tuesday. We're part of a .NET Foundation, so you might notice there's ones in Manchester, Newcastle, and there's a big cohort of them. And what we try and do is we bring everyone together, talk about .NET, bring speakers together, and yeah, build a community, as you've seen. And we've, over the past 6.5, 7 years, since we've been going, we've built quite a lot. So we've built the live streams onto our YouTube, which we use, and social media, and we started building it out to help build awareness of who we are and bring more people together. So if you don't want to be part of the photography, don't worry. Our cameras are pointing mainly at the speakers, but if you don't want to be in them, let us know and we'll try not to get you in. Other than that, a big thank you. There's more and more stuff to set up, more things to get out of the car and pack. So a big, massive thanks to the volunteers as well that help each month. And just under the scenes, it might not feel like a lot, but there's a lot that goes on under the hood monthly to set all these up, to coordinate with the speakers and coordinate. So just a big, massive thank you, because I couldn't do this on my own. And especially as well to our sponsors. We've not always been as fortunate to be able to splash out on new projector screens and give you the cinema experience, but thanks to these sponsors, we can, and we're doing really well. So we're going into a phase now where actually we're going to try and give back more to the local community through our charitable. So we're going to be building out some t-shirts, which we've got in there. I'll talk a little bit about in a bit. But Lily Chatwin, she's the sort of manager of Barclays Eagle Labs. A great place where if you want to come in for the day, they've got a free day pass. Strongly recommend it. Speak to Lily about that. You can go away and use the office rooms, the shared space, even free coffee. So it's well worth it for a day. And if you want to take it more than that, they've got some great rates. So it's great if you're working from home and you want a different sort of space, you want to come in and just basically socialize with people. And it's a great entrepreneurial hub as well if you're starting a business. So our first one, we've got a representative from Hyperloop here who is Alex on the side here. Only the best recruiters sponsor local meetup groups. So if your company's looking for talent or you know anyone who's looking for a job, connect them. That's why we're here for. People want to get jobs, so it's the perfect market to join people together. Another one close to my heart as well is a sponsor, is SNA Academy. The reason why I think these are so great is they offer free training. So a lot of people spend thousands of pounds to go to university to get master's degrees and security training. But secretly under the hood, your company have a budget and a levy that they can spend on training free provided by the government. So reach out to them. If you filled out the vouchers, the QR codes, you filled out one of our forms, there's an option in there to be contacted by them or be on their newsletter. But what it means is you can be kept up to date. So whether that's cybersecurity or you just want to go and learn something completely different, maybe you want to go into leadership, that sort of thing, they've got courses for you, even master degree equivalent that you can get for free, as long as they call it an apprenticeship scheme, but that kind of seems like you've just stepping into something. I don't think it is like that personally. I think the name is a bit misleading, but yeah, check them out. JetBrains 1-year product license. So today, at the end of this talk, we're going to be giving away a JetBrains license you'll have a 1-year subscription. If you've signed the thing and ticked the box saying you want it, you'll be in the draw. We're going to have an interval in between because we've got 2 speakers today. If you haven't, go and scan the QR code and you'll be in the runner-up for getting that at the end of the meetup. These t-shirts we're designing, we've got a few more. You might have seen them in the other room. Something we're trialing out. We're throwing a few designs together. We're using local companies to build them. We're designing them, having a bit of fun, and then selling them. And the profits we're going to be bundling up and giving away to a local charity. We thought we might as well try and do a little bit more if we can. So feel free to pre-order, or we've got a few to sell at the end of the event. Next month, very special, very, very special. We've got lightning talks. Come and give it a go. We've still got a few more slots, so 10, 15 minutes, not much. Just come and speak at the front about something you're passionate about. It could be .NET, it could be something else, something you've experienced in your work, your profession, or just something a hobby. I know a few people here have already said that they want to do it, so reach out to us through Meetup. If you're interested, we'll add you to the rota. It's a great way just to build your confidence in front of people, public speaking, so I highly recommend it. And that is everything I've got to put. I'm going to pass you on to Samson.
Hi guys, my name is Samson. A couple of people know me. Basically, a volunteer and co-coordinator for this meetup. In here most months. It's nice to be on the front seat. I'll just tell you guys a little bit about myself. During the week, I worked down in Liverpool for like a legal company in real estate data. And personally, I am a person that's in love with creativity. It doesn't really matter the form of creativity. I'm in love with creativity of all forms. And to me, creativity is, I express it in software development. A little something I read in passing that is going to be like of note in this talk is I read it sometime last week, something called the author's debt. It's basically a concept about when an author releases a book, a work of any book, any writing at all, the intent they had when they released it dies the second they release it. The meaning of the product becomes the interpretation of the consumer, and whatever they had intentionally intended that work to mean becomes irrelevant. That's something I find very key because it's like a key thing I believe in art, in creativity. I feel art is like impactful. The reason for art is its impact. That impact, as much as like the author has like, or the artist or the creator has a train of thought, something they've gone into while creating that art, the art becomes basically reflective on what the consumer sees it as. And just to, before we get to that, how that is relevant to this talk, I'll try to do like a little survey. So let's do a bit of survey about working with business experts. How many people here work with direct product supervisors or product owners, basically anyone that's invested in the company? Show of hands. And how many of those meetings look like this? A whole lot of them, I would guess. And one question, when someone asks you as an engineer, what product do you work on? What product are you building? What do most people go to? What do most people say? Do most people go to, I'm building a meetup application, I'm building a connectivity application, or do people go tell you, I'm building a cloud provision infrastructure on Kubernetes that offers real-time using etc technology implementations? This one is a bit funny. I was trying to compose a sort of really before piece of like business process, business function, trying to like replicate business function in code. Basically, this is meant to do something about creating a ride, and then it does a whole lot of things. Basically, the application is doing a whole lot of, yeah, a whole lot, a whole lot of things that it basically does. And how many of you can show this to basically a product owner and have them understand what this piece of business function is doing? Not a whole lot, I would guess, would understand. And that basically comes to the why of this talk. I try to like do a lot of things around the whys, the reason behind it. And the why of this is this miscommunication within the product. we build products to impact businesses, to enable businesses. That's what software is for, to enable a business, not to, we don't build, we build for software for fun, obviously, yes, but we also build it to enable a business process. It is meant for a purpose, and the purpose which it's meant for is enabling a business, and the business owners, whoever it's meant for, should be able to understand the product, not just have a different idea or visual of what the product is, and have people and have the product reflect a different thing. And I'm sure we can like appreciate how that is a problem, that miscommunication, that difference between saying we need to add on a new franchise to our business, and then the product engineer is telling the developers we need to add a new organization, and sometimes the CEO comes in and say, hey, we haven't added the new franchise, but when they tell that to the engineers or whoever is working on the product, no one knows what the franchise is. That's a very key thing that could happen between businesses when that miscommunication creeps in between the product and the business. The second thing is coupling. I'm sure we all know that we're all worried about coupling. Coupling, it's like a big thing in software. I think it's like part of like the most important things in software is trying to encapsulate, have basically scope. That's like a key point of this talk, scope. Software is about scope in different areas, different skills and perspectives about scope. It's part of our jobs as software engineers to understand different scopes and distill that, work towards that. Within this scope, this is the product we are building for this scope. This product belongs to a certain scope. Most of the products we use work on that same principle, the idea of understanding scope. I think that's like a very important bit of our work. So this talk is more about understanding the scope of business within software. And to do that, I'll be talking about a bit of strategic ways to think about software that enables you to think about scope in different layers and different levels. And no, this is not going to be a talk about technical implementations or technical details. It's more about strategic thinking, where how to reason around, think about software to be focused primarily on the business. So I know I've gone clean architecture, and it's basically probably been a bit, yeah, another talk about clean architecture, the buzzwords, all fun, all fun. But yes, it's a buzzword, but useful and helps solve a problem when there is a problem. And that problem in this situation is understanding scope. We can't move forward trying to build a business or try to reflect the business in the product when we don't know where the business starts, where implementation begins, where other parts of the product begins, and where the business ends. So ideally, generally, what most people would do, or what I would do when I'm faced with a problem where I have less, I'm able to like understand the scope, basically the product is distill scope, try to understand scope. And I'm going to be like talking about scope in different layers. And the first layer is trying to understand scope in the terms of related entities that change together. I use the word entities, basically related parts of the business that change, of the products that change together. The product basically is a working system of many parts that serve to a business purpose, and some of those purposes or part of those products are different. They change for different reasons. Basically, that's a scope we are trying to like distill. The first scope we're trying to distill is the parts of the product that change together. We're trying to understand, work towards the parts of the product that change together, isolate them in different scopes so that we're able to like focus, work on those products, have them do those particular things that they say they do, and work towards it together. So throughout this talk, I'm going to talk about four different, I would say, large scopes in terms of the products. A business scope, basically called a domain, that is focused on the business itself, what the business does. The application that's basically trying to have a scope where you orchestrate business processes, you orchestrate those business functions, those business rules, and the presentation is basically for user I/O, having to separate I/O from any other part of the business, as well as the last part, which is almost the biggest focus, important, but often when you find out is the least important part of the system, the implementation. So we'll talk about the business scope, what the business is. It's basically trying to, within the product, isolate the what of the business, the why of the business, the reason of the business, what the business does. Do we want to couple, I use the word couple again, do we want to couple, do we want to think about implementation when we are thinking about designing the business in the product? Do we want to think about do we want to think about modes of persistence? Do we want to think about how we collect data from the user, instructions from the user? Do we want to think about how we return this information to the user when we are designing the business? Not really, no. What we want to do when we are designing the business is design the business. We want to understand what the business does, how it does it, and most importantly, the rules that govern the business. Those rules I call invariants, rules that decide who is eligible to have a coupon, who is eligible to redeem a coupon, when a coupon is eligible to be redeemed, who is eligible to book a ride, what type of account accesses these services from the business. These sorts of decisions are what we try to isolate within a quanta, basically a scope called the business scope. Design the applications to basically focus on what that business does. And to design this product basically in software, I'll be talking about a few strategic tools that could help you reason about while designing the business in software. So basically designing what the business does, what the business looks like in software. And one of those most important, in my opinion, is something called context mapping. Basically, it's about understanding the business. So we've broken down from the larger scope of what the business done, and we've gone to a different scope. Within the business itself, there are different units. The business is basically a system. It's like a composition of various unit processes that work together to satisfy a business need, a customer need. And how does it, they don't do that in isolation, obviously, but there are still different units that focus on different things. The concept of inventory, the concept of, I'll use my example of the ride share app, the concept of tracking or basically user location, or the concept of managing user accounts. It's not really the same concept as billing a user for a service that was rendered. It's not the same concept as matching a user to a driver in the terms of like a ride application. Those are like different teams could handle those. It doesn't have to be different teams. It could be the same team handling it if the business is short on staff. And basically, I think, or rather, one of the very helpful tools that would help you be able to like reflect how the business functions within application is understanding that the business is made up of these little units where there are little isolated worlds that have different rules, different ways of reasoning about the business. So when you try to like design the products in a way as a huge unit that does all this type of things, you find yourself mixing concepts, ideas, rules within different units that are basically unrelated. And that's where you start to get one of your big problems, where we're coming from about coupling and a whole lot going on where it should not be going on. Second tool, language. I'm sure we all appreciate how important naming is in software. This is an excerpt from a book I love. I think it's like a very beautiful thing. The author is Patrick Rothfuss. He talks about the power of words and how important words are. And after he says a lot about how important words are, he says very important as much as they're important, they pale in comparison to the importance of naming, the idea of naming, giving meaningful names. When it comes to naming, often in engineering, you think about naming, or rather, I do think about naming in concepts of maintainability of code, of what a process does, what a method does, what an object is, does it, what an interface, a contract is, does it describe what it do, does this name describe what it do, so that not just myself, but the entire application reads in a way that I understand what it does by how I have named it. But names go just beyond that. Names play a very important role. It plays a role of bridging the products, the business and the products. I would give an example. The concept of payments within an application. Um, Within your application, within your product, you could have teams that understand that payment within the business is handled by a third party called Stripe. Within the application, the entire business or payment process of the business is named Stripe. Stripe client, Stripe API. And where does that disconnect come? The disconnect comes in telling the product manager telling you, we have a problem in the payment system, and the engineers or you yourself are trying to go through to understand where Stripe is within the business, within the product. Any point we get disconnect, miscommunication in information, in names, where the product does not speak the business language, the product speaks basically the technical language, implementation language, or the developer's language. The product speaks about joins, merge tables, merge fields. Yeah, speaks about like joins, merge tables, like it speaks about developer focused languages. The product doesn't reflect what the business does. The business is basically on a different tangent than where the product is. The product is reflecting the implementation, is reflecting the language of the developers, how the developers understand it. And where else could this be a problem? It becomes a problem in implementation, in try to say the truthfulness of what you're implementing, in the how the business process or how the business rules are implemented. The team or the business team starts to think about how the payments work. Does the payments work through a first reservation and then we have to do like a compensation for that product? Or does and are the developers, the engineers translating it as a different business process because of naming, the disjoint in naming? Is the team bothered about journey information? Say, what's the journey route? What's the journey route at the moment? Are there different teams? A team focused on the geographical location, a different team focused on the stops, where the user stops between the ride. This disconnect in naming brings about slowly and very huge important problems, where you're developing a different product towards what the business actually implements or what the business process actually is. And a different context, a different tool is bounded contexts. And this again ties into scope. We've defined isolated scopes. We've split those scopes into different units that specialize on what they do. But very easily, those business units could corrupt each other. I'll give like a perfect example is not from there, I'll say like a booking and let's say you have a booking business and an inventory where you have to coordinate, because obviously when you book for something, someone has to pay, you have to take that off the inventory, you have to compensate if that payment doesn't go through, that sort of information. But these two systems, they are two different units within the business, but they do often work together to perform different purposes. During your when you isolate or when you identify those different units, maybe you've not identified them as two different units, maybe they are one unit, or maybe they are two different units that do two different things. But when there is freedom, there's like laxity on boundaries within this business unit, you see that concepts between different business units begin to leak within each other. We go back to our previous problem where we have different units working together or being aware and compensating for parts of the business that they have no business being compensating for or being aware about. And that's why we think about the concept of bounded context. Basically, subdomains, isolated units. When you isolate those units of the business, you ensure boundaries. Within these boundaries, these are the rules, these are the languages within those boundaries. And the boundary is basically isolated or unaware of the entire any other part of the business. The boundary is an isolated unit that does what it does. It does as well. We go back to single responsibility encapsulation. It does what it does. It does it well. It focuses on just that. It doesn't try to compensate for consent from other units, other domains, and you get a whole lot of benefits from that. The benefits of I think the very biggest benefit for me is the ability to enforce your invariants, your business rules within a boundary. To be able to be very sure that within this boundary, this does this, it obeys these rules, it follows this particular set of instructions, and it does it well. Another tool I'll be talking about is, or rather within those bounded contexts, something else that benefits you could see from those bounded contexts. Different contexts with the same concept, but having different languages, basically different languages within those boundaries. This is like a perfect example I've come up with like this ride sharing app. The concept of like Johnny Roots. For like the booking team, what the booking team cares about is where do I have to pick this person up? Where do they drop between the rides? Where does the ride stop? I need that information to be able to accept the client's request or the customer's request and reserve basically match them to a rider, or basically all the logic or all the business rules that go within matching a client to a driver or accepting a booking offer. The location tracking team has to think about something different. It's still the same journey route, but what they are more concerned about is real-time location to be able to reflect that on maybe a map, a geolocation system to display that information back to the customer. That same information is still what the pricing team needs to calculate, estimate costs of a ride. But within these three contexts, within these three boundaries, it's the same concept, but it's different language and different meaning. This is like a very key thing you could benefit from having boundaries within each of these subdomains, where you're able to have each of those domains reflect the business languages, the same concepts, but still within the same languages inside the business, another different isolation within the scope.
Does this mean that journey routes is logic that
Logic.
talks to those contexts?
No, so rather the Johnny root is the concept. So it means like the name in Johnny root is the concept. It's like the same name, but has different context and concepts within each of those boundaries. So it means the same thing in the general scope of the business, but within each of those teams and units, very different meanings, very different things they refer to. Um, yeah, we just spoke about a bit of those benefits of setting these boundaries, bounded context. Few of those team autonomy, and a whole lot of those. I'll just be skipping through that. So we've isolated boundaries within the product. We've decided these are units that have no business relating with each other. We need to not be, these units do not need to be aware of the entire application, but the application still needs to work together to perform like a certain business function. Like example, booking a ride, you do have to work with the location team, work with the pricing team to be able to enable the ride to go through. So how do they each communicate? We've created another problem with it while trying to isolate. And that's why we entered the beautiful world of domain events in general. Eventing is or basically is basically a technique or a tool that enables you facilitate communication between your contexts without corrupting each of those contexts. You have contexts that make changes to their states and announce those states to the external world, sort of like a yeah, announce those changes, those mutations. So any change to the internal world or changes that that you decide the external world or other domains need to know about, and those contexts do not need to know what domains consume or make use of that information or do anything about that information. All they do is make changes, make decisions within the business, and announce those changes outside the business. And any other person within the business can interact, react to that, make decisions based on those changes. Those changes could be part of a single business processes that gets propagated down the chain to other business lines. And those business lines basically receive information about those changes, those state change, those mutation changes. And while there's like a little implementation diagramming for doing this in .NET. Again, this is not like a very implementation focused talks, more about strategy, so I'll be skipping past this. So I'll talk about transporting or coordinating this event within context, within systems. And there are lots of ways you could do that. Again, the method, the transport, the system of transport, it's really, I wouldn't say really irrelevant, but it's not the focus of the business. That's like implementation details. It could be anything. It could be like a Sega. It could be PubSub. It could be any sort of system that is able to like transport those information to the other systems where that information is needed. And while we do this, we sort of like introduce a different problem within the application, a very different problem. Earlier on, we spoke about isolating scopes and trying not to leak the contents of one scope within to another or one business context to another. But this sort of does that where we announce to the system that booking has changed, and then inventory has to compensate for booking. It becomes aware of the consents of booking, and the system becomes basically corrupted because it starts to handle or compensate, handle information or states or logic about another business unit that is entirely unrelated. And that's why we have beautiful tools like anti-corruption layers. These are basically just translators, in my opinion, systems that intercept events, that intercept notifications from the outside world, translate that into the language of the particular domain or the particular business context that that information is coming to. So basically what that does is it listens to those information or listens to information where it has interest or that's relevant to the business, takes in that information, translates it into what is relevant to the business and passes that on to the business context. So the team in essence, basically at all points, only receives information of what is relevant to them or relevant to them in that context. So basically I'll try to like lay in a couple of talks about technical tools, being able to like reason about designing these types of systems as objects, as products, as basically software products, because you do have to design them as software products. Think about how to design these objects that encapsulate these rules, this isolation, this context, this domains. And I'll just be talking about a few of those tools. One of them is, or the most important one, is being able to model them as objects. So basically, within a business, there are basically two types of, I would say, scope, two types of entities, two types of entities that exist within a business. And one of them, one important one, is an entity whose in which the business is interested in its life cycle. That's like the perfect way I'll describe it, from its ideation to its end, and even after its end, the business is interested in its life cycle. An example is, I would say, myself. The government probably knows me by a number on my visa. They basically knew information about me from the second I got that identification in my visa, and that information continues to live within the business. The government knows my life cycle throughout my existence within the system, and even outside that. A second concept is something I call value object, something that something that represents properties, states, basically. They represent states, but not identity. I'll give like a perfect example, length. So say you're measuring the length of this room. You're not really bothered about the particular 10 meters that make up this room, but you know that this room is like about 10 meters long, but you don't really need to know which particular part of the ruler measured out that 10 meters, or which particular 10 meters actually is the 10 meters for this room. There won't be a different 10 meters here and then a different 10 meters for the next room. That basically is a property basically that describes, it's a descriptive property that tells you the value or state at a certain point, but you're not interested in that object, you're not interested in that entity past what it describes. And this is basically what a value object and entities are, and how things you could consider or think about when designing objects for business. Um, Third one, I've sort of like skipped over aggregates. Aggregates are basically empty entities, to be fair, and they are basically your boundaries. So when we've spoken about bounded context, etc., earlier, they are basically, I would say, God objects. Depends on how you design them. There are a couple of ways to reason about when designing aggregates, but they're basically invariant boundaries within a system. They decide what changes, what happens, how the parts of the system interact with each other. They decide how the components that live within that domain, that context, interact with each other. They basically are a boundary that you decide or you design to contain the rules within the system. So they make the final decision about the changes that make within the system. No changes happen within the system unless it goes through a central entity. Say uh, for example, what I give now. Sorry.
It's not a bunch of entities changed in the same transaction.
The same transaction. So yeah, I'll say like batch of entities change, but in like how I reason about them are more like boundaries. So basically, not just because they change in the same transaction, but because they decide the boundaries within which the entities they contain are able to change. So the rules the entities make are basically coordinated within the aggregate. They make the decision on how these different types of entities within that boundary are able to like relate with each other, how they're able to like change. So basically, you're not having two different entities within the same context making changes in the system that's at different places. So think about it in coordinating various objects that make changes at different places. They make this particular entity makes a change, this particular entity makes a change, announces that to the outside system. It basically takes us back to the beginning where we have loads of entities interacting with each other with no boundary, no certain structure to compose those rules, a central place to compose those rules. So that's how I reason about entities, a central structure where you compose rules, ensure that these rules are made, and any mutation within the system have to be decided by the rules you set within the aggregate, not just within the individual entities. So I've given like a little code sample for value objects and entities, and I'll share the slides after this if you're interested in any of this. Uh, Something else, repositories, this I would like skip past. I know this is like a pain point for a couple of people, repositories, because we have pretty good ORMs in .NET, especially now, and a couple of languages. They're very mature ORMs that do a lot of like beautiful things, orchestration and all. And there's always um, it could be like an over engineering, over complication when you try to have basically repositories that do the same things ORMs do. But I would like give certain use good use cases for repositories. Repositories are basically objects of persistence and retrieval. They basically help you to hydrate business entities, domain objects within memory, um, persist them, hydrate them within a contract. So basically, the entire idea or one of the very important techniques around reasoning about designing business like this is designing towards contracts, having straightforward contracts of how entities change, of what performs what sort of actions within the system. I had like a code sample set up, but that would be like if I have time after the talk, I'll whip that out on my laptop. But basically, the repository contracts help you hydrate the system, basically sets the system at its previous state, updates the system back at the previous state, and then you make your whole decisions and rules in memory when you hydrate them. And another important thing or use I find from having repository contracts interfaces are having descriptive methods that make data interaction basically within the system. So there are a couple of yeah, basically. Uh, I did do a couple of code samples for this. I'll again share this after the talk on the slides. So perfect. We're done with the domain context, the domain scope, the business objects. How do we get this information? How do we get these different systems working with each other to perform a business use case, do something for the customer, take information from the customer, report information from the customer. Let's give a tiny little look down there. You have your beautiful context doing their beautiful isolated works together, and then you have to compose that on a UI to the user. You have to compose that information back to the user. And we have those contexts directly building out the user experience, user interaction with each other. We go back to the first problem we had, where we had different systems working together without any sort of isolation or scope, trying to build out a context. So how do we solve that problem? We solve that problem by trying to abstract abstract a process of composition, of interaction, of business rules. How do these business basically components react with each other? How do they perform different processes to lead to a final business function or business decision? We sort of like compose the interaction between these systems. We don't try to create another abstraction of making business rules, but rather orchestrating the objects that make business rules. And something beautiful you could gain from that is you have common common code, common functions, common things that happen during interaction with users and the external system. You could slap like a pipeline in front of that, have stuff like authentication or etc happen on like a common system without having to again model that with the business process that you're trying to like do. And that's like a beautiful thing you could gain from doing that. Oh, domain reporting. So we've spoken about performing business processes, taking information from the user, reporting those information back. One of the first things I learned about the computer is computers are garbage in, garbage out. It's like the very first thing I learned about the computer. Computers basically have two ways of interaction with users, with us users. We make instructions to the users and we receive information back from the computer. Most of what we've spoken about have been about how to make decisions about like a business rule, a business process. But when we make those decisions, we also return information to users. We have users asking us about their ride history. We have to tell the user we've booked your ride. We have to tell the user, these are the payments you've made in the past couple of months. And we've gone through the very painful work of building out our domain, building out our system, or thinking of designing our system in isolated contexts where they don't interact with each other. But when we try to like give this information reports back to the users, we see we need information from both the location tracking, booking, pricing at the same time to report one single information to the user. And then we say, oh, how do we go back and get back all this information back to the user? So we think about a very useful tool, command query segregation. I won't go into saying CQRS again and that buzzword, but again, tools exist where they help you. The entire idea of reasoning about how you make mutations within the system and how you ask the system for information, how you query the system, ask the system for information, is not just about separation of infrastructure or trying to make things faster or any sort of concerns. I think the major reason why you would benefit from reasoning about how you make changes to the system and how you collect changes in the system is it gives you options, it leaves your options open. What you report, the information you report, it's been like a very long tool in software. We talk about analytical processing and transactional processing, where you think about how you design reports differently from how, sorry?
Query is not something what's it's a bunch of information designed to help you make decision what you want to do next, from my perspective.
So sorry, I didn't get that.
Okay, maybe the queries is a bunch of information that you collect together to help you make decision what you want to do next.
To do next. Yeah, I think that's right. So basically, it's basically rather than
because mainly you don't need to use the storage, you might collect
from different places, exactly.
bring them together as okay.
This is the information you need
to know to make
about
decision.
it. Yeah. So that's basically why I've tried to like talk about it, not just being about the data sources or the places the data lives, but rather about mentally thinking about different pathways where of how you mutate the state of the system and how you ask the system for information, because the places the information lives might not even be in the same environment. It might even be in the same environment. So all that, the implementation doesn't really, I would say doesn't matter, because obviously it does matter when you build the application, but basically when you think about designing the application, the core benefit in my opinion you gain from thinking about the way you mutate the state of the system and ask the system for information is you have opportunities. You start to have different opportunities in things you can do, ways you can improve, mitigate, or compose data. You have different options. You get the options. Basically, that's like the biggest advantage I see is when you get that option to think about how you retrieve the data. You're able to like make decisions that are effective for retrieving data, reporting that data, different from how you mutate the state of the system. So again, code examples. I'm going to skip past this because again, strategic talk, not really about like the code. The infrastructure, I spoke about like having like a scope called infrastructure, concerned about like implementation details. We just went through building an entire application without thinking about the infrastructure that powers it, medium of transportation. The programming language even wasn't even something that was like most important when you're thinking about the system. The infrastructure, in my opinion, is implementation of the rules you've set. You decided this is how the business works. I want the business to do this. And you become free, you become left with the option of deciding in real time how or what you want to do those things, how you want to do those things. It doesn't have to be a changing system where you're trying to design for future changes that actually in honesty rarely happen, where you decide, oh, I need to move to this, except like depending on the skill. But you become left with the option of deciding how you want to do it. at any point without being bothered about influencing the business decision or how the business runs. Why? Because you've isolated that scope. And we just go to finally the presentation. A perfect example I've had for like this presentation. Sometime last month I was speaking to someone about this, and say you want to see a video on YouTube. You're not really worried of YouTube is not really worried about this how they display that video to you on this projector, a television, or a mobile phone, or a laptop. They're worried about displaying information to you. The channel, the medium by which you take information and display it back to the user is not part of the business or what the business does. What they're interested in is the main business itself. Being able to isolate that scope of the main interaction with the user basically is able to receive information from, the system is basically able to receive information and pass information back to the user. This becomes like that's basically the front part of your application where the users interact, where you're able to like get information from the user and like send back information to the user. It's like becomes like that scope on its own. I'll go to a couple of pros. Most of the things we've tried to like establish throughout the talk, being able to reflect the language of the business in the product, in the code, getting clear boundaries, clear invariants, clear boundaries around business, flexible change, which we know doesn't really happen in a lot of products, but the options are there without having to make any extra work or rethink about design, and you're able to like build an application that is business process first. That's what I mean by process modeling. You design the application from the business utilization first rather than the implementation first. You see, you start to like think about designing the application on its use case rather than designing the application towards its implementation. Cons, all good things have bad sides. Very important, it's expensive. By expensive, I mean time consuming when there's no trying to get the whole team involved if there was no prior experience doing this. It does need discipline because a whole lot of most of the strategies I've talked about were going around creating scopes, isolating scopes, and very, very easily, it's very easy to let these different scopes leak into each other, get into different systems. So there's a whole lot of governance that goes into this isolation. Easier when you have like couple of contracts and they're able to like define things, but still very difficult and needs a whole lot of discipline. When to use it and when not to use it, or good fits and bad fits. My most perfect example of a good use case would be a business that has a lot of rules as to what a business process is, what a business function is, what determines. So basically, rich businesses that have loads of rules about how to perform a business action or business process. So basically, you're trying to design a data scraping application. You're not basically thinking about the business rules in data scraping because the bot is basically just going to retrieve something, pass it, and that's it. So those are like different things to think about when designing this. Is it worth it to design an application towards the business if you're not designing it for a business process that actually is or application that actually reflects business? That's all. That went faster than I thought. So any questions? I'm taking questions. No questions?
I've got a note to say the last slide. It's
Yeah.
great. Normally people are like, this is the best thing. Always. Everybody's.
Just use it.
Or like throwaway story. It seems like if you don't know, like exploratory
Yeah.
design, not a good fit. Not a good fit. And the pros, like if business stakeholders can take part, I might go one step further and say like where they're willing to invest and they will take part.
Time as well.
Because the way that it often goes wrong is when people are like, oh yeah, this is how it works, and it's how it always works, and always will,
And
you
then I'm going
bake
to
all
put all
that
the
in,
resources in there.
and it's not an invariant.
Yeah. Could go really bad real fast. So
Or high risk scenarios where the risks are high, so you need to plan for
high reward or high
those kind of
failure.
processes where they're going to be in place.
Yeah.
You know, 'cause I did that for 16 years in healthcare because killing a patient seen as a one bad thing. Some reasons.
Exactly.
If they live, they live. It's fine.
Thank you so much, guys. You reach out to me on via email. I've written like a tiny little library. Still, basically, it's still being written. Just a couple of things I tried to get about as practical implementations for basically microservices in .NET. So do check that out as well. And we'll be taking a short break soon, I guess.
Yep.
It's open source, yes. Cheers, guys.
Okay, so we're going to be, thank you. So Samson's done it incredibly well there. What he didn't tell you was that is an hour and 40-minute presentation, and he cut that down to fit into 2. So where he's rushed into sections, yeah, we need to get him back and do some more. I think you've got another video somewhere on it. So I'll share that around the full video where he talks code as well. Sorry about passing the microphone as well. So if we've got any questions at the end, I'll pass the microphone around. Otherwise, on YouTube, it just looks like he's talking to himself, and people ask questions. What was the question? Yeah. So yeah, let's take a short break, 5 minutes. Get yourself a drink, comfort break, and we'll be on with the next talk. Thank you.
John. I work with NHS Informatics, just at KB over there. My background cuts across finance, healthcare, and fintech. And currently, I'm trying my hands on little stuff like building these two companies, more especially the second one with some people over here. Next Sulo is a property management app that tries to automate the process of management of tenants by the landlords. Why Infinity MyQ is just a technology company just trying to build websites for something cheap for people that want websites and web applications. These are a few of my hobbies, and I think this is my picture in my new office in Liverpool. Yeah. So back to what brought me here today. Building a smart RAG system with Qdrant and OpenAI in .NET. I'll start by asking what you think about onboarding a new staff, and I can imagine all of us here work in the tech industry, and perhaps you have onboarded a new staff, and all of you are busy in a project, and the new staff needs to start working. But then for him to start working, he needs to ask a lot of questions. He'll probably go to his supervisor, where can I get IP address for this? How do I set up IIS? Who do I talk to for the billing, for strike payment system? I think it's not working. Who do we talk to? Just those kind of questions. He will keep, it's just forth and back. Then every 5 minutes, 20 minutes, he's asking supervisor this question or this question. But what if you have a knowledge base where you have a wiki, you have your SharePoint, all of them put inside a database, such that when you onboard a new staff, instead of the new staff calling different staffs to ask questions, he just type, where do I get how do I deploy on IIS in our office? And it gives you a total breakdown of what to do, where to, the IP of the DNS, the IP of IIS server. It gives you a breakdown of that, and he starts off working without disturbing the senior guys that are working on the project. So what answers this is RAG. So it's about building a knowledge base, loading the knowledge base with a lot of information, wiki, documents, as many as you think that is necessary, and then building the logic that instead of asking LLM question directly, that's ChatGPT or Copilot, the question is going directly to vector a database before getting to LLM, and then you retrieve the answer. So let's look at it. So standardly, look at how LLM works. A user sends a query like, who is the Prime Minister of UK? The question goes directly to LLM, that's ChatGPT or Copilot or any Gen AI that you can imagine. It gets an answer. But this question is very simple. Who is the Prime Minister? What if, in the other case, you are asking, who do I contact for Stripe payments? Let's assume our company is Xcode. Who do I contact for Stripe payments for Xcode? What will happen? it means that there is need for us not to go straight away to LLM because LLM might not have the answer. So first, we have to introduce a knowledge base, which could be any of the vector databases. Well, I'll talk more about that. Then we search the database, get top answers, join the answer with the query, the first instruction, then pass it to LLM, then get a very well contextual answer, which is now sound for the process, which gives exactly what the user is asking for. So this is what we call RAG. That is, RAG means retriever augmented generation. We are retrieving from a knowledge base, we are augmenting it. The augmenting there is adding the search results to the instruction. Then generation is the part where you send it to LLM like ChatGPT or OpenAI. So what are the benefits of RAG? One is that it gives you a real-time answer. This approach overcomes the limitation of static model. Like you don't need to be training the model all the time. If we were to rely on putting our SharePoint into the model, we have to like buy our own or build our own model where we have to train the model all the time. But there is no need building your own model where you have the likes of OpenAI, ChatGPT. Then lastly, it gives you a domain-specific answer. It doesn't have to hallucinate. It doesn't have to make up. All it gives you is whatever is in the knowledge base. That's the block diagram of the RAG system. Forget about the picture. So let's look at the system RAG subsystems. The first subsystem is the data ingestion and processing pipeline. It consists of the document loader. What is document loader? Document loader here is a system that is capable of loading PDF, text, document, docs, video, audio. But for us to talk about document loader, we need to understand what is chunking or text splitters. And text splitters are nothing but a way of converting the document that you've loaded into the system to small chunks. And when you talk about chunks, what is chunk? Chunk is the smallest significant it could be a word, it could be a chunk is a word or the smallest bit of the smallest meaningful bit of a sentence. It could be a, d, of. These are chunks. It could also be a space as well. It depends on the model that is making use of the chunk. The next is embedding model. If after chunking the data, instead of using the big data, instead of using the documents, because a document can contain up to 5 pages or 10 pages or 1 page, and you know that each page can contain up to 500 words, but you don't load those 500 words straight away to the database. There might be need for you to chunk it, cut it into maybe 200 words or 200 chunks, as the case may be, 50 chunks, whatever suits your design. So when you chunk that, the next thing you need to do is to convert the chunks or convert this sentence into a numerical, uh, in, into numerals, which is otherwise known as vector embeddings. For proper understanding of vector embeddings, we try to understand the difference between, we try to pay attention to what is called semantic search and lexical search. Robert the other day talked about semantic search. I think he dwelt on that for a very long time. But today, I want to pay more attention in the demonstration of how it works. I wouldn't be speaking a lot of grammar today. But for us to understand embeddings very well, we need to understand the difference between lexical search and semantic search. The traditional way of searching before now is the lexical way of searching for information, whereby you are searching for keywords. If you are looking for, if there is a sentence that says Liverpool is located in the Midland, if you are searching for Liverpool if you are searching searching with a keyword Liverpool, it will be targeting just the Liverpool without checking the context surrounding the statement. But if you are using semantic search, it will check. Okay, let me use a better sentence here. Let's say we want to search for this person called Daniel Radical. He is also known to be very rich and an actor who played Harry Potter. Now, if you are doing a lexical search of this particular person, using the lexical search, it will just query the DB directly to return just Daniel Radical without giving you any other thing. But what if you use how rich is the actor who played Harry Potter? Because we're using semantic search, how rich is equal to net worth when you use vector embeddings, because vector embeddings break down each word into embeddings such a way that if you put in a particular embedding, it can match it with another embedding, whatever it is. So with this semantic search, we will see that we're able to get the exact information we needed about this particular person, Daniel Radical or Radcliffe. This other information is the difference between lexical search and semantic search. But that's just by the way. Now, I want to explain more about vector embeddings or word embeddings. The term word embeddings, as I've said, is a way of representing words in a numerical form or representing it as an array of vectors. In vector embeddings, instead of storing words directly as text, you rather store it as numbers. The size of the number is determined by the kind of model you're using. Some model use as large as 1,800 and something. Some models like text embedding tray of OpenAI use about 3,000 dimensions. But it all depends on the model we are using. Now, assuming we are using a model that uses just 7 dimensions, we could describe a man with this attribute, whereby we have gender. Let me use my own system. So we could have a man to have gender 0.9, while a woman has gender minus 0.7. In this case, you can see that for that particular gender, it's giving exactly the opposite. Sorry, slightly the opposite of a man is woman. If you go to human, you see that both man and woman are human. And if you go to royalty, this one is crazy. It says women are more loyal than men. I don't know about that. You can see man is minus 0.1, while the women is 0.1. So, but this is just how to capture embeddings, how to capture the meaning of words into embeddings. But this is made up embedding, not actually any defined model. But that's this explanation will give us a better understanding of how word embeddings work. But it's still how NLPs work. Word embeddings helped natural language processing to generate meanings, as in generate different embeddings for about over 17,000 or 170,000 words that we have in English. Yeah, when we store it, we use similarities like cosine similarity to find the ones nearest to each one. Cosine similarity comes in when you want to find the nearest neighbor. But we'll get to that. So these are different types of embeddings that we have. And we have more, but I just listed these few. We have text embedding 3 small from OpenAI. We have text embedding 3 large for OpenAI, which has about 30,072 width or size. We have the ones from Olama, All Mini, from Microsoft, 348, 384, and the rest of them. But for the sake of the demonstration I'm doing today, I am working with text embedding 3 small, just because my Olama is not really performing. The system I have is, if I send just what is my name, it could take up to 5 minutes before you return. So I have to use OpenAI. So still on the subsystems of this design, we have vector database. So another important system that we're going to be using is the vector database. And the vector database we are going to use is the quadrant database. This is how it looks. The quadrant database, unlike the traditional databases, is optimized for similarity searches. Instead of using the likes of Oracle database, which is a relational database which stores records in rows and columns, we are rather using a vector database which stores information with respect to the ID, the vector, that's the embeddings, and the payload. So these are the 3 most important parts of any record stored in quadrant database. So for quadrant database, in case you want to explore it, it's free, partially free. If you store it on your local machine, it is free, but online, it could cost you if you want to go beyond 4 gig. So, but for the sake of this project, I'm using the free version online. If you want to use the ones that is free for all size, you have to install it on your local system. So I'll be demonstrating how quadrant database work, but let's move ahead. So for Qdran database, it makes use of clusters, collections, vector, and points. The clusters is equivalent to database servers, while collection is equivalent to tables, and points are equivalent to rows. So other subsystems we'll be dealing with is the retrieval part. Retrieval and generation. We'll be using a user interface. In my case, I'm going to use Swagger as the user input. Querying the embedding. The .NET orchestration will be used in querying the embedding. So when we talk about querying the embeddings, first of all, we have to okay, let me proceed. So the next is vector search, context augmentation, large language model, orchestration system. So I want to discuss more on the functionality of this rack system. Because of time, I want us to see how vector database works, how similarity search can be implemented, how we can do document loading and chunking, and finally, how to query based on the knowledge base context. So I would switch to a demonstration. Sorry. So how many of us have used Kudran database here? Pinecone. Oh, okay. Oh, that's good. Some some recommend Chroma. Oh. Sorry. Oh, Sam, you might need to come. Okay. Okay, so look at, this is how Qdrant's database looks like. Okay, this is exactly how the interface looks. So like I said, you can access it either through the dashboard or you can access it from maybe an API. That's through Postman or from your code. So when you subscribe or log in, you see this kind of interface. All you just have to do is to create a cluster. If you create, it creates a cluster. I've already created a cluster already. These are the spec of my cluster. 4 gig, 1 gig RAM, 0.5 CPU. So if I get into my cluster, I would see this. If I go to the console, I have 4 collections. That's like 4 tables out of 1,000 that I have access to. So I have this cluster, these collections, document collection, my blog, my profile, technology. These are, let me call it tables for easy understanding for some of us that are new to it. So assuming you store something into a Qdran database, if you click this, it opens it up. This is a knowledge base I've stored over here. It sees this as a record. This one as another record. If you copy this, it gives you the vector equivalent of this particular sentence. But let's see how to create a simple collection.
So question for the document collection you just showed, the different clusters, are they like chunks? Are those different chunks? Because it look like it's a paragraph was split into two, and the second one started from when the first one started.
That's one problem with chunking. I don't know why I shared this one first for you to see, but okay.
Scroll down.
Yeah. I wanted to explain some things, but I skipped just to meet time. I might go back to it, but I'll explain what you are talking about when I hope there will be time to come back to it. So let me come back to, let me walk you through how to create collections on vector database. So if you go to your console, or let's try something new. So if we go to quick start, creating a collection, we have this payload. The basic parameters or properties of any vector database you're creating is the size. Like I said, I told you that for the text embedding tree of OpenAI, the dimension is 1,800 and I think that's something. But for this test that we're trying to do now, let's just use a simple dimension 4. Then the distance is the similarity type. It could be dot, it could be cosine. I don't want to explain the mathematics behind it. So if we run this, it creates a collection for us known as star charts. So I've just created a table. Let me call it table. And it's okay, but this is called collection now. So it created a collection with 4 dimensions, and the type of similarity is going to use is dot instead of cosine. So the difference between dot and cosine is the dot makes use of a product. The higher the dot value, the higher the similarity. But for cosine, it ranges from -1 to 1. The higher the value, if it gives you, if the similarity is 1, it means that the two embeddings match each other. If they are far apart, like -1 and 1, it means that they are totally opposite to each other. Now, after creating the collection, the next thing you create is the point that you are inserting table. You're inserting records into a database table. Now, if we run this, it inserts all these records into the collection. So we've inserted first record with this embedding. This is a made-up embedding. And the record itself, the payload itself is, the colony is mass for this. The colony of this one is Jupiter, Venus, Moon, and Pluto. Now we have these 5 records. If we go to the Kudra database, if we refresh, we'll see our star chart. We can see 5 records. If we open it, we can access it to see what is inside. So we can see the record inside here. You can see colony mass. If you want to see it graphically, look at how it looks in 2-dimensional plane or in graphical form. If we do the same thing for Jupiter, look at how it looks in vector form. Now, we can actually want to query, if we go back to this, our query, we can actually query by the vector or by any vector, finding the top three that is very closer to this. If I could look at this very well, 02, 01, 09, 07, if I look at it very well, I would probably say that it resembles this. So what it means is that if I query the top three with this, I should be seeing, this one should come up first. If these dimensions are similar to this, that means mass should come first. But that's an assumption, but let me run it. Oh, that's almost opposite, but at least mass came second. So, but this is us querying the top three similarity based on this vector. Okay. Oh, that's just an example of how to access quadrant database. Then let's look at the code part. I have created an API, a .NET API, which has this. So for the sake of this presentation, I have this. So the first part is the chunking part. The second part is the upload. The chunking part will help us to understand a bit about chunking. Now, but before we look at chunking, let's upload a file. So what I want to do is this. If I go back to my quadrant database, I have documents collection. I want to delete this document so that I can put my own, another document. So I don't have documents anymore. Documents collection. Now, I have this information here. I just made up this. I just asked Gen AI to generate a partnership deal with Stripe Payments, mentioning the manager that handles the accounts, Sarah, technical support person, John Ramirez, John, yeah, his phone number, the charge is this. Now, assuming in your company or in our company, we want to implement RAG. So what we need is to load this document into our Qdran database. So by the implementation I've done, all I just need is to call this API, attach that document, then execute. It would go through the process of chunking it, converting it to embeddings, and storing it into Qdran database. So let's go back to our Qdran database. Let me refresh. So I now have this document. That's the document you talked about. But before I open it, I want to just open it without storing it. I want to look at this chunking. If I run just chunking here, this is not going to store it. It's just going to chunk it and return results here. So look at what it got for us. I don't know if it's clear a bit. It's readable. Bros, it's actually because of you that I'm opening chunking. So if I do operate on document loading and chunking it, I would get this. So I have chunked it with, I'm doing 50 chunking and, sorry, think I'm doing 520, 500 words and 20 overlaps. Let me confirm what I'm doing. Okay, so I don't know if you can see the code a bit. So during document loading, you decide the size of the chunk and the overlap. So what does it mean when you talk about 200 as chunk size? What it means is that if you have a word, if you have a document, you try to read the first 200 words. If you read the first 200 words, that's the chunk size. But sometimes the 200 words might not be very meaningful because you might not have an end of line after the 200 or around just close to the 200. You might need to go further beyond 200 before you get a full stop or before you get a paragraph or before you get a new line. So there are different models or implementation for this, but the best is using LangChain. This is where LangChain comes in. LangChain can make use of recursive splitter or can make use of GPT-4, or you can write your own algorithm for the chunking such that all you want to do is, instead of loading the whole PDF into a database, which might not really make sense because PDF can have as big as 500 pages, you want to break it into chunks, into maybe 50 words, 50 words, 50 words that are meaningful. But for each 50, like in this case, 200 words, for each 200 words, you want it to be meaningful a bit. It might not totally be perfect. So around that 200, once you get to 200, you want to check between the overlap of 50. Do we have a paragraph within the next 50 chunks? If we have a paragraph, you break it after that 200 chunks. That's where you get a paragraph. If you don't get a paragraph after that first 200 chunks, you look for a next sentence that's a new line. If you don't see a new line, you look for a dot. I don't know if it makes sense a bit. So that's how to get your first short document. So that's how a recursive splitter works. But if we use GPT-4 chunking system, it works similar to that, but it's recursively, if you're using chunk of 200, when it gets to the first 200, if you use an overlap of 50, the first word will be around 150. Then the next sentence will start from 250 to 200. Sorry. Let me explain this better with this. Okay, I try to explain this here. So I'm trying to explain chunking using 30 words and 5 overlap. So if you have a document and you want to do 30 chunks and 5 overlap, what it means is that you take the first 30 tokens or chunks from the document as the first chunk. Then the second chunk, you do 30 minus 5, which means you are starting from position 25 to the next 30. The next the next time you do 25 plus 30, that's 55. You start at 55, you move to the next 30. This is how you keep doing, but it might not be very, very smart. But if you want to adapt the smart way, use GPT-4, which is very close to getting you something, a meaningful sentence after each break. So that's how, sorry? Okay, so why we have the overlap is that if you are doing, uh, if you are tokenizing with 200, that when you get to 200 tokens, you might not have reached the end of a meaningful sentence. Maybe you are looking for the boy is good, and the boy is the 200. Good hasn't entered. So you have to have overlap to accommodate good. So the overlap is, if the overlap is 5, so within the next 5, you're looking for a full stop or next line or paragraph so that you can break it. So it now depends on the algorithm or the model you are using. If you are using some algorithm, they will count back 5 before they start another one. If you are using some other algorithm, they will try to look for when a sentence starts, they will try to look for the start of a sentence, like what recursive splitter does. But the most intelligent is GPT-4, the model used by ChatGPT.
Is there a reason? Is there a benefit to giving all the collection of chunks if you consistently size? Because you would think of a document was read in paragraphs or in sentences. Or, you could just parse it like that, but obviously you get some big paragraphs and small paragraphs. Is there a problem with doing it?
So we are doing chunking to capture, to just get paragraph. We want to store the information in our vector database paragraph by paragraph by paragraph. So we assume that a good paragraph has like about 200 chunks, 200 tokens. That's like 200 words. But you probably want to give bigger overlap, like 100, such that if you get to 200 and the sentence hasn't really ended, you give some space, some overlap for you to be able to get that. Then,
So why would you have to pick like 200 words or 2 tokens? Why wouldn't you just say parse this document into paragraphs? Because that gives you the most contextual coherence, why don't you just say whatever paragraph size is, give me that?
I believe that is what the likes of GPT does. Using more intelligence to store that.
Most important word is in next chunk. For example, like color, for example, the set of the first chunk is the set of the single word, and the single word is in unavailable. You lose full meaning. With that, say, okay, I've got one block, but it's not enough information. Maybe I'll something another block.
Okay, yeah, so let me round off because you don't have time. So,
if you start using ChatGPT, for example, to store all these, to create these chunks, right? And at some point, you don't want anymore pay ChatGPT and the tokens, all that stuff. And you want to use another model that is not, it's different. You can do it, or is not.
so in terms of chunking, you probably don't need to maintain a particular model.
You with all this number of words, right? And you pass to chat GPT to get that embedded the vectorial number, right? To set inside the database.
Okay, so where I use ChatGPT, not ChatGPT per se, where I use OpenAI is when I want to convert a chunk to word embedding, to a vector embedding. That is when I use ChatGPT, sorry, where I use OpenAI. So that when I want to retrieve it from the database, Kudran database, I'll also use OpenAI to transform it back to words. Do you get? But for chunking, any model, any algorithm works. So let me be quick to the end. Hi, sorry, can you listen? Are you with me? Okay, so we have this document. We have this document stored in the Kudran database. Now, the question is, how do we make use of this document? If we look at it, let's ask a simple question. If we ask who manages the account of Xcode, this is an agreement between Xcode and Stripe Payments. Can you see that? Now, we can ask a question, who manages Xcode accounts or who in Stripe Payments manages Xcode accounts? Let me ask this question for Rag to give us an answer. I've got all this, but I want to rush down to Rag because of time. So this question is already here. So before asking any question, you have to put the context. The context is the collection name. That's the table name in this case. So if we ask who manages the Xcode Stripe payments, if we ask it, sorry? X what? So if I ask the question, what do I get? Look at what I get. The management of Xcode Stripe payments is handled by Sarah Thompson, who is the designated Stripe account manager for Xcode. If I want to ask more questions, what phone number can I contact Sarah Thompson with? I will get an answer. So instead of going to search all the documents, SharePoint, Wiki in our organization, all I need to do is ask our own RAG system question. It makes use of the Kudran database, refines it with LLM to give us a very contextual answer and accurate with no hallucination. Just let me ask it, what is phone number of Sarah? What is the phone number, or what is Sarah's Thompson's contact number? Let's see what it will say. So it gives us Sarah Thompson's contact number is this. So with this, we get accurate answer, and we don't, the newbie that just joined the organization gets an answer for everything he wants. Once we have loaded all the wiki, SharePoints, and documents of our organization in this RAG system. Yeah.
You're able to source where the information is coming from. So if you have multiple documents in the RAG system, are you able to know what document it came from and which page in that document it came from?
No, I'm not sure it's able to read page, because you can create a document without putting page numbers on it.
Oh, but without the page number, will you be able to know like which document it came from? So like the example you given before, SharePoint,
Like a reference source.
yeah, like a
Okay.
reference point.
Yeah, so if there's several documents mentioning Saratoga, yeah, which is you're going to come back with the correct information.
Maybe during the loading, you have to be attaching the source so that it can understand the source. Huh? Sorry? Yeah, metadata information. You could probably put metadata for each document you load. You put a metadata so that when you want to get more information, you could get. Not inside the documents that you are loading. Mm. So, any other question? So, if no other question, I would hand over to.
Thank you very much. Thanks to everyone for coming along today. We've switched up to Thursday today. We usually don't do Thursdays. We usually have every week on Tuesdays. Can you help us out with the? Thank you. So we're expecting to see everyone and more people come along with friends next month, same time on Tuesday. So next month we'll be doing the lightning talks. If you're interested in speaking about something, anything at all you're passionate about, it doesn't have to be about .NET or technology. We just want to hear you talk. We love listening to people. Just reach out to us on either Instagram. No, we're not Instagram. YouTube. Like Meetup and LinkedIn. Time for the one of the good parts of today.